Here's problem 1421. Water pressurized at 3.5 times 10 to the 5 pascals is flowing at 5 meters per second in a horizontal pipe which contracts to 1/3 of its former area. What are the pressure and velocity of the water after the contraction? Well, we have a couple things going on here. We're going to have to employ the continuity equation to this pipe as it constricts to 1/3 of its former area. So let's say that the area here is A and the area here is 1/3 A. So, and we have point A and point B. So we have, by the continuity equation, the following: that the area at A times the velocity at A should equal the area at B times the velocity at B. So in this case, the velocity at B then would be equal to the area at A divided by the area at B times the velocity at A, which is going to be equal to A over 1/3 A times the velocity at A, which is 5 meters per second. A is canceling out. 1 over 1/3 is 3, so this is going to be equal to 15 meters per second. So the velocity at the constriction is 15 meters per second. Sounds good. Now we can try Bernoulli's equation for these 2 points A and B. So we have the absolute pressure at A plus 1/2 the density velocity at A squared plus density G height at A is equal to the absolute pressure at B plus 1/2 the density velocity at B squared plus the density G height at B. Well, everything is on the same height. So if we define our height all the way through here as being 0, then our height at A is 0 and our height at B is 0, and we don't have to worry about our rho GH terms. We are given the absolute pressure at A, and we wish to find the absolute pressure at B, so we're going to solve this for the absolute pressure at B. That's going to equal the absolute pressure at A plus 1/2 the density times the velocity at A squared minus the velocity at B squared. Just solving for absolute pressure at B. This is equal to 3.5 times 10 to the 5 pascals plus 1/2. The density of water is 1,000 kilograms per meter cubed, unless otherwise stated. Velocity at A is 5 meters per second. Square that minus the velocity at B, which is 15 meters per second squared. And this is all equal to 3.5 times 10 to the 5 minus 1.0 times 10 to the 5, or 2.5 times 10 to the 5 pascals. So the pressure at the constriction is lower because the fluid is moving faster. The water is moving faster. So the water is moving 3 times faster with a velocity of 15 meters per second, and the pressure at the constriction is lower after the contraction, and that is 2.5 times 10 to the 5 pascals.